We just worked on our last lesson on dividing radicals, and on all of those questions, we did not end up with a radical in the denominator. So in this lesson, we're going to talk about what happens when we do have that situation. So one of the stipulations, as we talked about, is that there are no radicals in the denominator of a fraction. So what we're going to do is we're going to have to multiply the top and the bottom by the same term, and it's going to be some term that will make it work out nicely. So for instance, let's take a look at this one. I have the square root of 4a squared and the square root of b to the fifth. So just as we did before we broke it down. When I reduce the top, the square root of 4 is 2, the square root of a squared is a. And in my denominator, I have the square root of b to the fifth. So 5 divided by 2 gives me 2 b's on the outside, but I still have a b left over, and that's not okay. So what I'm going to do is I'm going to always look at the index. I know that I need 2 of them in order for it to come out of the radical. So I only have one b on the inside. So what if I took it times another b on the inside? Well, then I would have 2 b's on the inside. So it's however many the index tells you to do. So what do I have left? I have 2a and radical b. And on my denominator, I have b squared and then radical b times radical b. But those two turn into a b. So I have 1, 2, 3b. So I have b cubed. That would be my final answer. So again, I multiplied it looking at the index by however many I needed to make sure that a full b was able to come out of the radical. So let's take a look at a couple together. On the first, I don't have to break it down into 2 parts because the radical is only over the denominator. So I'm looking at my index of 4. I know I need 4 x's on the inside of a radical in order for 1 x to come out. I already have 3 x's. I just need 1 more. So I'm going to take the top and the bottom times the 4th root of x to the first. Now what's going to happen is my numerator is just going to multiply to be 3 times the 4th root of x. My denominator is 3 x's and another x, so 4 x's. So it's the 4th root of x to the 4th, which of course is just x. So that's my final answer. And for the other, again, I don't need to do anything with the radical because there's no radical on the numerator, but I do need 5 y's in order for 1 y to come out, and I only have 1. If I need 5, that means I need an additional 4. So I'm going to take this times the 5th root of y to the 4th and the 5th root of y to the 4th. My numerator is 2 times the 5th root of y to the 4th. My denominator is 1, 2, 3, 4, 5 y's, but the 5th root, which just gives me y. So again, it's all about whatever that index is. On these two, the first one, notice I've got the radical over the entire problem. So again, I would break it down into the parts. So the square root of x cubed and the square root of 5. My numerator would reduce to x and then radical x. My denominator would not reduce. And so it's just radical 5. Now I know that my index is 2, and so I need 2 5's in order for a 1 5 to come to the outside of a radical. So I'm going to just take each times the square root of 5. My numerator, I have an x on the outside, and on the inside an x and a 5, so square root of 5x. My denominator, radical 5 times radical 5, is 5. Notice that those 5's will not cancel because the 1 5 is on the inside and 1 is on the outside, so they're different. And for my other, I've got the cubed root of 3y squared, so this is more complicated. I need 3 3's and I need 3 y's. So I only have 1 3, so I'm going to take it times 2 more 3's. And I have 2 y's, but I need 3, so I'm going to take it times 1 more y. So I'm taking it times the cubed root of 3 squared y, or just 9y is fine if you want to write it as 9y. So on my numerator, I've got 18 times the cubed root of 9y. For my denominator, I've got 1, 2, 3 3's, and I've got 1, 2, 3 y's, and I'm taking the cubed root of that. So now this is my answer, except now I see that I've got an 18 and a 3 that are both outside, so that's different than what we had over here. 18 divided by 3 is 6. I still have the cubed root of 9y on the numerator. On the denominator, I just have a y. That y will not cancel with the y on the inside of the radical. Sometimes you end up with something a little bit crazier as your denominator. So notice this is not one term, now it's two terms. And in order to deal with something like that, we will multiply by the conjugate. The conjugate is the same two values, so the 3 and the radical 2, but we're going to do the opposite operation. So what I'm going to do is I'm going to take the top and bottom times 3 minus radical 2. And something really cool happens here when you take it times 3 minus radical 2. The numerator, nothing really cool is going to happen there. So minus 4 times 3 is minus 12. Minus 4 times minus radical 2 gives me plus 4 radical 2. On my denominator, however, remember this is sort of like the difference of squares pattern. We're going to take 3 times 3, which is 9. This value is going to give me minus 3 radical 2, and that's going to give me plus 3 radical 2, which is going to happen every single time you multiply by a conjugate, which is why we do it. And then radical 2 times minus radical 2 gives me minus 2. And notice these two are gone. So my denominator is now 9 minus 2, which is 11. And then on the numerator, I have negative 12 plus 4 radical 2. Nothing I can really do about that. So this would be, oopsies, I did not pay attention to the minus. Just kidding, this is not 11, this is a 7. 9 minus 2, turns out it's 7. So this would be my final answer, and I would not be able to reduce anything. Here's another where we have to multiply by the conjugate. So looking at the denominator, radical x minus 7, I would have to multiply by the conjugate, which is radical x plus 7. But if I do it to the denominator, I obviously have to do it to the numerator. So for my numerator, I have 4 times radical x, which is 4 radical x. I have 4 times 7, which is 28. I have radical x times radical x, which is x. And radical x times 7, which is 7 radical x. We'll worry about reducing those in just a little bit. For my denominator, radical x times radical x gives me x. This gives me plus 7 radical x minus 7 radical x. Those will cancel. Minus 7 times plus 7 is minus 49. Now let's reduce what we can. So on my numerator, I have an x. I'm going to write that one first. I have a 4 and a 7, so 11 radical x, and 28, plus 28. And then x minus 49 on the denominator. And that's all I can do. Try these two on your own and then press play to see how you did. For the first, I'm looking at an index of 3. I know that I need 3 of something in order to be able to reduce it. Now, some people would say, okay, well, I've got 25 and I need 3 of those, but that's going to get a little bit crazy. So instead, think about your denominator as the cubed root of 5 squared x, and that will make things a little bit easier. So if I'm going to multiply by something, I need 3 5s, and I have 2 already. So I'm going to multiply by 1 more 5, and I have 1 x, but I need 3, so I need 2 more x's. So the cubed root of 5x squared. My numerator is 15 times the cubed root of 5x squared. My denominator is just 5x. The 5's, of course, will reduce, so 15 and 5 would give me a 3 as a numerator, and then cubed root of 5x squared. The denominator, that 5 canceled out, and so I just have an x. And for the second, I'm multiplying by the conjugate, which would be 3 plus radical 2. 3 plus radical 2. And I'm going to have to do some foiling on the top and on the bottom. So my numerator would be 15 radical 2 plus, this would give me 5 times 2, which is 10. This would give me minus 6. And then minus 2 radical 2. foiling the denominator, I would get 9, and then I would get plus 3 radical 2, minus 3 radical 2, and then minus 2. I promise to subtract correctly this time. So on the numerator, I have 15 and minus 2, which would of course be 13 radical 2, and these combine, of course, to give me 4. So I'm going to write 4 and then plus 13 radical 2. My denominator is 9 minus 2, which is 7, and that's my final answer.